Now we have sum number 15 from CBSE 9.1 exercise. A straight highway leads to the foot of a tower. Okay, so here we have a straight highway leading where? To the foot of the tower. This is your tower AB. Here's your highway, okay, leading where? To the foot of the tower. Now, a man standing at the top of the tower. So here we have a man standing at the top of the tower, observes a car at an angle of depression of 30 degree. This man is observing a car at an angle of how much? 30 degree. So for angle of depression you need the horizontal line. So PA is the horizontal line. With respect to that we have this angle of depression as 30. Okay. Then which is this car which is approaching the foot of the tower with a uniform speed. Speed is constant. Speed is not changing. 6 seconds later, the angle of depression of the car is found to be 60 degree. After 6 seconds, this car, here is the car. It is approaching the foot of the tower. So after 6 seconds, it was found that the angle of depression is how much? 60 degree. This angle. This angle is of 60 degree. Okay. So this is your angle of depression, which is of 60 degree. Fine. So here is your position, new position of the car. After 6 seconds, this is the position of the car. Okay. After 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower. How much time will it take? This car will take to reach here. Okay. Now, as such, in given, we won't write much about it. Given AB is the tower, right? AB is tower. C is the car. Angle PAC is angle of depression, which is equal to 30 degree. Angle PAE is again angle of depression for the second position of the car after 6 seconds, which is equal to 60 degree. Time taken to reach the point E is equal to 6 seconds. What do we have to find? To find time taken to cover this distance, time taken to reach the point B, that is foot of the tower. So for this much distance, how much time will be taken? For distance EB, how much will be the time taken? We have to find out. Okay. So first of all, we will simply go by, we will forget about the time, we will forget about the speed. First of all, we will find out the distance. Distance with respect to angle 30 and distance with respect to angle 60. Okay. Now as these angles are of angle of depression, so by alternate angles, this angle will be of 30 degree and this angle will be of 60 degree. Fine. So first of all, we will go for the smaller triangle in your solution in right triangle ABE. This is your right triangle ABE. Okay. Angle AEB is equal to 60 degrees since alternate angle PAC is equal to 60 degree. We haven't written initially, so in reason we will write since alternate angle PAC is equal to 60 degree. Therefore, tan 60, tan ratio is opposite upon adjacent. This is the opposite for 60 degree and this is the adjacent for 60 degree. So opposite is AB, adjacent is EB. Tan 60 is √3. So your distance AB will be how much? Or this AB is equal to how much? √3 times EB. This is your equation 1. Fine. Now we consider second right triangle. In right triangle, now this right triangle we are taking ABC. Angle ACB is equal to 30 degree since alternate angle, which is that alternate angle PAC. This alternate angle PAC is of 30, so ACB will be of 30 degree. Since alternate angle PAC is equal to 30 degree. Therefore, tan 30 will be again this tan 30 will be again opposite upon adjacent. Opposite is AB, adjacent is BC. So AB upon BC. Tan 30 is 1 by √3. So AB upon BC. Therefore AB will be how much? BC upon √3. This is your equation 2. Now if you compare equation 1, AB is √3 times EB and AB is BC upon √3. We have the left hand side of these two equations the same. So the right hand side will be equal. So we write now from 1 and 2. From equations 1 and 2. √3 times EB is equal to BC upon √3. Okay, let us cross multiply. √3 into √3 becomes 3. Thrice EB is your distance BC. Okay, so 3 times EB is this distance BC. Fine. Now, BC, if you have a look, is made up of BE plus CE. So we put it here. Therefore, thrice EB is equal to CE plus BE. Segment addition property. CE plus EB. So therefore, thrice EB minus EB is equal to your CE. Fine. So how much will be your distance CE? It will be twice EB is CE. So this distance CE is how many times BE? Twice BE. This distance CE is twice BE. Okay. Now, if you read the sum, it says 6 seconds later, the angle of depression of the car is found to be 60 degree. Initially, the angle of depression was 30 degree. After 6 seconds, now we come to the formula. Speed is equal to distance upon time. So So therefore distance will be equal to speed into time. Okay. Now when the distance covered is CE, when the distance is CE, time taken is how much? 6 seconds. Speed is constant. So we assume it to be as 1 kilometer per hour, as such unity. We assume it to be unity. So when the distance is CE, the time taken is how much? 6 seconds. So look here. For constant speed, the distance for constant speed, the distance CE takes 6 seconds. Okay, so CE is equal to 6 here. See, distance CE is equal to 1 into 6. We are taking speed as uniform, so we are considering speed as unity. So distance CE will be 1 into 6. So CE is equal to 6 seconds. But what is the CE? This CE is twice EB. So in place of CE, we write therefore twice EB from here. Twice EB is equal to 6. So EB is equal to 6 upon 2, which is equal to 3 seconds. So to reach the foot of the tower, how much time will be taken? 3 seconds. Distance covered, that is ED, it takes how many seconds? 3 seconds. I hope you understood this part of the sum. What is given to us? Again come to this sum. It says that a man standing at the top of the tower observes a car at an angle of depression of 30, which is approaching the foot of the tower. Okay, angle of depression when it is 30. The car is trying to approach to the foot of the tower. After 6 seconds later, the angle of depression of the car was found to be 60 degrees. From here, the man is observing the position of the car. So 6 seconds later, this is the new position of the car. What do we have to find out? The time taken by the car to reach the foot of the tower. So time taken, when we are considering, we are using the formula speed is equal to distance upon time. Distance will be equal to speed into time. You have been given that the speed is uniform. See in the sum, it is moving with uniform speed. So we consider the speed as constant. The speed being constant, the distance covered will be 1 unity into the time taken. Distance is equal to the time. So when the distance is CE, the time taken is 6 seconds. So when the distance is EB, okay, so the time taken will be how much? It will be 3 seconds.